Okay, this is a lesson on section 10.5, graphing hyperbolas not centered at the origin. So the first thing I would like you to do is please pause the video and work on the following warm-up. Okay, so let's go over this. First off, number one, to get this into a form that we can graph it, the first thing we're going to do is divide by 576. And I'm sure, as most of you have figured out by now, this ends up to be x squared over 36 minus y squared over 64 equals 1. And what this tells us is that because it's x squared minus that, the curves are going to go like this. I'm going to pull up the answer because it's going to be much nicer than me trying to graph it. And I'll walk you through it. Okay, so here we go. Because it's x squared over 36, I went right 6, and I went left 6. Then I went up 8. I want to point out that this scale is counting by 2's. So I went up 8, and on this scale, notice 4, again, counting by 2's, 8. And I went down 8. And then I built the box. And so I connected, and ooh, that is really, really thick. There we go. We built the box. You can see I drew my dotted asymptotes through the box. And then I put the curves so that they were on the vertices on the x-axis because it starts off x squared. And then the asymptotes are just going to be y equals, and so if I count the slope here, I'm counting up 4 and across 3 or down 4 and across 3, and that's why it's plus or minus 4/3 x. The vertices are at 6, 0, and negative 6, 0. The foci are at positive and negative 10, 0. Because here I want to add the denominators together, and that would give me 100. The square root of 100 is 10, so I'm going to go right and left 10. So number 2 says, write the equation of a hyperbola whose center is at the origin and has vertices at plus and minus 4. Well, as soon as I say that plus and minus 4, I know immediately that this is going to be a 16, because that tells me that I'm going right and left 4, and so 16. So minus y squared equals 1. Now, if I add together 16 in the other denominator, they need to have a square root of 5. So that means 16 plus b squared has to equal 25. We've played with these numbers so many times, it should be automatic. This is a 9. Okay, so here are the answers from practice A. Take a moment, pause the video, and check your answers. If you have any questions, you can ask in a few minutes, or you can come see me at lunch tomorrow. Okay, so what we're going to do today is we are going to work with hyperbolas in completed square form that are not centered on the origin. This is going to look a lot like our lesson on ellipses off the origin. The only difference is they're hyperbolas, and there's going to be a minus sign. But the process of completing the square is going to be the same. So just like before, it's going to be x minus h and y minus k. All the rules we learned yesterday for hyperbolas and how to build the box and where to put the vertices are going to be the same. So right away for number 1, I see I've got a center at 2, negative 1. I see I have a center at 2, negative 1. I see underneath the x's I have a 9, which means I'm going to go right and left 3. And I've got vertices at, so 2 plus 3, and then 2 minus 3. All right, so I want to make a graph here, and I want it to be kind of accurate and get some straight lines. All right, so I'm going to start by putting my center at 2, negative 1. So there's 2, negative 1, and I'm going to put my point down. Now I want to count right and left 5. So 1, 2, 3, 4, 5. Put my point there. And then 1, 2, 3, 4. Whoops. Where did the 5 come from, Mrs. Strauss? That was ridiculous. Should have been right and left. Oh, because I saw the 5 here. I want to count right and left 3. So 1, 2, 3, put a point, and then 1, 2, 3, put a point. All right, I'm also going to be going up and down 4. Now this is different. Again, just like yesterday, it's not the bigger number that determines the major. 1, 2, 3, 4. That's actually 5, so it should be here. And then 1, 2, 3, 4. All right, so now I'm going to dot out my box. So that looks kind of like my corner over here. There we go. All right, I'm going to make my asymptotes pink also. Pink is kind of going to be my dotted line color for the day. So, oh, that's not so good. Let's try again. So here's one asymptote, and then here's the other asymptote. All right. Now, because it starts with x equals, I'm sorry, not x equals, because it starts with x squared, my curve is going to follow the x vertice, not the y vertice, even though it's bigger. So I'm going to bring the curve out and stretch it against the asymptote, just like yesterday. Ooh, that one was a little slower getting there. And then this side. Ooh, that one was really slow getting there. All right, that one's just terrible looking. Let's start him over. And, well, you'll just forgive my bad graphs. Oh my gosh. There we go. All right, close enough. So we have the center, we have the vertices. We don't have the foci, we don't have the asymptotes. So the foci from the center to the foci. Remember, this is going to be a little different from the ellipse. I'm going to add the denominators. So 9 plus 16 is the square root of 25. I'm going to be going right and left 5. So from the center, right 5 is going to be 7. And then left 5 will make it negative 3. Now, the asymptotes are going to be different from yesterday. Yesterday, because everything was centered at the origin, it was easy. Now, things are centered other places. Now, this one, it might be here on this point at negative 3, but I'm not sure. Because I'm not sure about the y-intercepts here, I'm not going to use y equals mx plus b. I'm going to use something that you might remember from Algebra 1 called point-slope form. You must write this down. This is point-slope form. If I know that my graph passes through a specific point x1, y1, and has a slope m, this is a formula I can use. It comes from the formula for slope. You just drop off the y2, x2, and you multiply by the denominator. Because I'm not using this equation to produce the graph, I'm just using the equation to write, the lines, it's fine that it's not solved for y. You're going to use this equation a lot in calculus when you don't need to graph the line, you just need to write the equation. So here we go. Y minus, well, again, I'm going to use the center. So y minus negative 1 becomes y plus 1. Just like yesterday, I'm going to count the slope. I can count up 1, 2, 3, 4, and across 3. Or it could go down 1, 2, 3, 4, and across 3. Let's be smart lazy about this. We're going to write it as plus or minus 4 thirds because we are going either up 4 or we're going down 4 and across 3. And then times x minus 2. This is the part that is going to cause people the most problems because the ellipses don't have asymptotes, and it's the newest. So there are the asymptotes for number 1. Let's take a look at number 2. So for number 2, now we need to start completing the square. And this process is going to be a lot like it was with an ellipse. We're going to group together the x's, and we're going to pull out the 9. So it's going to be x squared minus 2x plus space. Then we're going to group together the y's, and we're going to pull out. Now we want to be super careful because we're pulling out a negative 4. We're going to add the 42 to both sides, or 43 to both sides, plus space, plus space. So take a moment and think about what we're going to write on the spaces. All right. Negative 2 divided by 2 squared is 1. But 9 times 1 is 9. 4 divided by 2 is 2, squared is 4, but then times negative 4 is actually going to be minus 16. I'm going to take this and make it 9 times x minus 1 squared minus 4 times y plus 2 squared equals, and then the arithmetic here, 36. I'm going to divide everything by 36. And now I've got x minus 1 squared over 4 minus y plus 2 squared over 9 equals 1. When I go to make the graph for this, I want to remember, once again, the x's are coming first, so that's where the major axis is going to be. I have a center at 1, negative 2. Now, because I'm working on the active slate and the graphing is kind of messy-o, I'm going to model for you how to find all this stuff before graphing. So there's my center. I know the vertices are on X, and I know they're going to go right and left too. So the vertices are going to be 3, negative 2, and then negative 1, negative 2. Add 2, subtract 2. The foci. If I do not 4 plus 9, oh my gosh, it's root 13. Whoa, it's not a pretty number. Life goes on. I'm going to add and subtract root 13 to the 1. Now, again, I'm going to do this before. I'm going to make a graph, but I want to show you how this can be done without the graph. For the asymptotes, again, I'm going to use that lovely formula. And if you didn't write it down the first time, you better write it down now. All right, so we're going to have y minus the center equals the slope. Well, let's think. We're going to be going up and down 3 and right and left 2, because 3, 2, and then x minus 1. So I have found all these properties without producing a graph, which, I'm going to be honest with you, is probably going to be a little ugly. But let's try. So we've got a line, and we've got a line, and let's switch colors, and it's got to go 1, negative 2. Where's the 1? Oh, because I'm on horizontal 1. Hey, switch, bummer. There it is. So 1, negative 2, and we're going to have a point there. All right, so now we're going to go right 2, 1, 2, and put a point for the vertice, and 1, 2, and put a point for the other vertice, and notice they are at 3, negative 2, and negative 1, negative 2. Now to build the box, I'm going to go up 1, 2, 3, down 1, 2, 3. I'm going to get my handy-dandy little box maker because I can't make a box with the active slate or it's going to come out looking like a parallelogram. And we're going to go box. Oh, that's not bad. So now we're going to put in the asymptotes. Again, these should be dotted lines when you graph them. I just have extreme difficulty making a dotted line. So there's the other asymptote. All right. And then because it's x first, point to the curve, point to the curve, point point to the curve. All right. We're going to do a few more of these. I'll tell you what, why don't we just do one more? Then you can start your homework. Move these guys out of the way. All right, so I want everyone to write down number 3, and I'm going to give you a head start. I'm not going to talk. I'm going to let you work, and I'll just start writing. And so you can look up when you think you need a little hint. The one thing I am going to point out is look at this negative and look what it's in front of. That tells me when I start to get organized, I might want to put the Y's first. So I might want to start like this. If you still need more time to work, pause the video because I'm going to start explaining my work. The first thing I did was I grouped the Y's together and I grouped the X's together, pulling out the -4. Then b over 2 squared is 9 and 4, so I have 9, but this one's really -16 because I pulled out the -4. Then I did 11 plus 9 minus 16 became 4. Factored and divided by 4 gives me this result. Now, when I go to graph this, I want to be really, really careful. And the reason I want to be uber, uber careful is that this is a hyperbola that has its vertices on the y-axis and not on the x-axis. And what that means is I just don't want to end up backwards in all my work. So here we go. The first thing I'm going to do is I'm going to remember my center is not 3, 2, it's 2, 3. These are still all my x values, and these are still all my y values, even though the y values come first. So I'm going to go 1, 2, 1, 2, 3, point. Then I'm going to go right 1 and left 1 because that's under the x. I'm going to go down 2 and I'm going to go up 2 because that's under the y. I'm going to get my pretend dotted line pink and I'm going to build the box. Then I'm going to take my pretend dotted line pink going to put in my asymptotes. Again, all the pink work on your paper needs to be dotted. It does not really exist. They are just guidelines for us to make the graph. I'm going to get rid of dotted line pink. Now, because it's Y, the curves come up and run along the asymptotes here. I did all this work before I graphed by noticing that I'm going up and down 2 from 3. So 3 plus 2 is 5, and 3 minus 2 would be 1. The foci, add my denominators together, I would get 5, and the square root of 5 is just the square root of 5, and I'm going 3 up root 5 and 3 down root 5. The asymptotes come from 2 and 1 as the slope. So plus or minus 2 over 1 is 2 over 1. The center is at 2, 3, 2, 3. At this point, I want everyone to get out Making Practice Fun 55, and I want you to get started. I'm going to page forward so you can see the answers as you work.